This video provides a complicated example of using the square root property, which states that if a variable squared is set equal to a constant, then we can invoke the property to write that the variable is equivalent to plus or minus the square root of the constant. But sometimes it's hard to see that you're in that situation. Let's take a look a little bit more deeply into the heart of this equation, where we see our variable exists inside a set of parentheses, and they're held captive by this exponent squaring it. And that's the only place our variable exists. So let's try isolating the variable to see what kind of equation we really have. And we'll start as far away from the variable as possible. We can't really break into this expression until we get this -2 away from it. And the -2 is being multiplied. So we're going to undo that by dividing by -2 on both sides of the equation. And that leaves us with q minus 3 quantity squared is equivalent to positive 24. So a negative over a negative is a positive. 48 divided by 2 is 24. And now we see we are indeed in a square root property situation, and we can invoke the property by writing that the base, q minus 3, is equivalent to plus or minus the square root of the constant, 24. So let's clean this up a little bit. Oops, just gonna resize my screen a bit and give us some more room. So the square root of 24, well, we can rewrite 24 as 4 times 6. So we've got a perfect square right there, but 6 is just 2 times 3, so there's nothing that we can do. It remains a 6. So the square root of 4 times the square root of 6 is going to be 2 roots of 6. So first we can rewrite that as q minus 3 equals plus or minus 2 roots of 6. And then we can add the 3 over to fully isolate the variable. And we'll end up with q is equivalent to 3 plus 2 roots of 6 and 3 minus 2 roots of 6, the two solutions that both satisfy the original equation.